I'm Richard Wilkes, and this is my video report for assignment 2 of my 217 physics game, Lawn Bowls. Firstly, what you are seeing here is footage of my game, wherein the players are able to turn in order to aim their ball at the desired target. The player can also choose their speed using the 1, 2, and 3 keys. The first triggers a light throw, the second triggers a medium throw, and the final key will execute a heavy throw. This will allow the player to close the gap or choose how hard they need to throw in order to get close to the targeted ball. In order to allow the player to choose their desired speed, I have set some simple cases wherein if the keys are pressed, it will set an acceleration speed. This speed is determined by a float which takes in the heading times by the move speed, which is pre-decided, and then this is times by the acceleration float. This gives the effect of throwing with initial power but decay, which will be explained later on in the video. As for rotation, this is a line of code which uses the GLM rotate function in radians in order to decide which angle the heading is on. This is bound to the left and right arrow keys. In this part of the video, I will be covering the decay of speed and the forces that are associated with it. As seen in this footage, the ball is thrown and then starts to slow down. This is a constant slowdown rate and is not changed by how fast the ball was thrown, but rather the changes in the forces that reduce the speed faster as the power of the ball was low. Here is the code that determines the slowdown rate of the balls in the game. This is relatively simple. There are 3 cases. The first 2 deal with stopping the ball, whether or not it moves forward or backwards. This is done by adding force or speed in the opposite direction of the current movement. All this is a speed check, and when it has determined which direction it is moving, it will apply the appropriate speed to stop the ball. The third case is to bring the ball to a complete stop. This is because of the multiplications of speed between the acceleration float. As this number will never be exactly 0, I have created a case to do this. When the speed is barely moving the ball, it will set the acceleration to 0 in order to stop stuttering and movement. Here I have provided a diagram of the forces that are enacted upon the balls as they are thrown and as they move. You will have the gravity pulling the ball to the ground, which in turn generates friction from the floor, which reduces the speed over time. The green arrow represents the initial energy from the initial throw. In this next piece of footage, you can see the curve of the heading for the ball that is thrown. This is something that the player can do using the previously mentioned rotation controls. This will enact a curve on the ball's path. This final footage shows the collisions of balls. This is simple. If the balls hit each other, then the ball will collide with the other ball that was hit. The collision works at multiple speeds, but is using cube colliders. This has an inaccuracy of collision compared to spherical colliders. However, seen in the footage here, they work well enough for this purpose. Here is an image that shows how the collision works. The collision works by comparing the distance between the min and max of each collider in order to determine whether they are inside each other's bounds. Here is the code which determines the collider's center points, which will be used to calculate whether they are intersecting for a collision. In conclusion, I think that the implementation of the speed control, the rate of deceleration, and the rotation-based aiming went well and work well enough. However, the main weaknesses in this game is the curving of the ball, which is determined in post-throwing, which is unrealistic. Also, there are the colliders. Although they function well, they do not pass the speed into the balls that are hit. This is unrealistic, as the speed would be passed into the ball that was hit. In future with this project, I would fix the issues mentioned earlier in order to provide a more realistic game. Thank you for watching this video report.